Okay, guys, before we move on to compound inequalities, let's do a few more. So we're going to distribute the -3 to the x and the 1. On this side, we're going to go ahead and combine our like terms. Now remember, when you have variables on the left and variables on the right, we want to get those together. And so we're going to add 3x, and we can see what happens is the variables will be eliminated, and we're going to be left with a false statement. -3 is not greater than -1, and -3 is not equal to -1. Therefore, there is no solution. So we're not going to graph this. And for our notation, we're just going to use what's known as the empty set. So it's just our French curly brackets with nothing in it, or we can just use the null symbol. So we have the empty set. And again, you're not going to put anything here, not even 0, because 0 would be considered a solution. So you just leave it blank. Or we can use the null symbol. Okay, this time we have a problem where our x value is on the right side. So we're still going to just solve it as normal. We have -21 is less than 3 times x. We're dividing by a positive, so we're not going to reverse the symbol. We're going to have, if we keep it as it is, it says -7 is less than x. If we want to write it so we can read it from left to right, right now we say x is greater than -7. We're going to turn the entire statement around. X is greater than -7. So I didn't flip the inequality, I flipped the entire statement. Okay, now we're going to graph this. So we're considering -7. We have -8, -6. It is open, -7 is not included, and we're going to shade everything to the right because x is greater than. And so our set builder notation is x is an element of the real number system such that x is greater than -7. And then now let's take a look at interval notation. So we can see that -7 is not included, so we're going to use parentheses. And again, we're going to positive infinity, and we never include infinity. So we're going to have, we bring it just straight down, just like we see here. We're going to list the -7 first, and then we're going to list infinity because it's our larger value. So again, always have your smaller value on the left and your greater value on the right. Again, you're reading from left to right, just like you read on the graph. Let's do one more. We're going to subtract 8 from both sides. This is going to give us 16 is greater or equal to -2x. Now look here, I'm going to start this one because we are dividing by a negative, so we are going to reverse it. We get a -8 here. I'm going ahead and reverse the inequality, and we have x. So I did reverse it because we divided by a negative, but I'm going to flip the entire statement just so my x is on the left side. So I say x is greater than -8, and then when I read it from left to right, x is still greater or equal to -8. So we're considering -8. This time, my solution set does include -8, so it's closed, and we're going to shade to the right. We're going to infinity. Our set builder notation, x is an element of the real number system, such as x is greater or equal to -8. Our interval notation, -8 is included, so that requires a bracket, and then we're going all the way to infinity, which requires a parenthesis. So bringing this straight down, I have from -8 all the way to positive infinity are my solutions. Okay, pause the video, and then we'll come back. We'll work these out together. Okay, guys, we're going to distribute. We have -2x minus 8 plus 4x is less than or equal to -12. We're going to combine like terms, and so we have 2x minus 8 is less than or equal to negative 12. We're going to add 8 to each side. I'm going to bring this over here. 2x is less than or equal to negative 4. We're going to divide by a positive number, so we keep the inequality symbol as is. I'm going to graph this. So we have negative 2, negative 3, and negative 1. And then my solution set does include negative 2, and then we're shading everything to the left, going toward negative infinity. So when I write my set builder, x is an element of the real number system, such as x is less than or equal to negative 2. And then when we do interval notation, we're going to have from negative infinity all the way up to negative 2, including negative 2, so brackets. So I'm going to have negative infinity, comma, negative 2, bracket. And remember, this does not represent an ordered pair, just our solution set. Okay, we're going to multiply 1/2, which is the same as dividing by 2, so we get negative 4x minus 6 minus 2 is less than 24. We're going to combine like terms. We are going to, let me bring this over here. We're going to add 8 to both sides. We get negative 4 is less than 32. We're going to divide each by negative 4, each side by negative 4. I'm going to star this one, and this is going to give us, oops, I forgot my x, guys. Sorry about that. So this is going to give us x is greater than negative 8. I reversed the inequality, and so we're going to graph this. We have negative 8, negative 7, negative 9. Our solution does not include negative 8, and it's everything to the right going toward positive infinity. My set builder notation is x is an element of the real number system, such as x is greater than negative 8. And then we have our interval notation. It does not include negative 8, and we go all the way to positive infinity. And so we're going to have negative 8 all the way to positive infinity, so 2 parentheses. Okay, now let's take a look at compound inequality, where we're either going to use the word and or. And so we have an example here. So if we have x is less than 5 and x is greater than 2, that means the solution set is less than 5 but greater than 2. So you can see here that it's sandwiched in between 2 and 5, and 2 or 5, neither one are included. So this is an example of compound where we're using and you see the overlapping there. So here is one where we have or, so our solution set is either greater than 5 or it is less than 2. So you can see these are going in opposite directions, and we have this section where none of these numbers, 2 through 5, are part of your solution set. So you want to pause the video and write this in your notebook, and it'll explain when we're using and, all the things that occur, and when we're using or. And you're going to want to pay attention to these symbols down here. And so pause the video, write this in your notebook, and then we will come back and continue with some problems. Okay, here we have negative 3 is less than 3x minus 9, and 3x minus 9 is less than or equal to 12. So you can solve it just as you see it, where you have to do whatever we do to the middle, you're going to do to the left side, and then you're going to do to the right side. Or you can break this down into two separate. So let me show this. We can have negative 3 is less than 3x minus 9. And then we would have 3x minus 9 is less than or equal to 12. So we're going to solve this. We're going to add 9. And then we're going to divide by 3. And it says 3 is less than x, or I could say x is greater than 3. Okay. And we're going to add 9 to both sides. divide by 3. So let's graph this. So we can we'll have 3 here, 4, 5, 6, 7. So 3 is greater than, x is greater than 3, not included. And then let's take a look at the second one, and x is equal to 7 or less than. So you can see right here where it is sandwiched, where they overlap, that is going to be our solution set. So let's do set builder notation. So we have x such that, x is an element of the real number system such that, so we're going to have these two sandwiched together, and so it's the union. So we're going to sandwich x, and so x is greater than 3, and it's also less than or equal to 7. So you see where I have x's in the middle, so we're sandwiching it between the two boundary numbers. And then interval notation, let's get another color. And so we have 3 we're gonna have a parentheses at the 3, and then we're gonna use a bracket for the 7. So we're gonna have 3, 7 with a bracket. Okay, here we have or, so we're just gonna solve these separately. X is greater than 2, or x is less than 8. So we have 2, 3, 4, 5, 6, 7, 8. Let's go ahead and put our infinities. And x is greater than 2. And again, it's not included. And we have x is less than 8. So this is an or. So these can be my solutions all the way to positive infinity from 2, and then from 8 all the way to negative infinity. So that really, you can see, guys, since it's an or, it can be this or this. It doesn't have to be both. So we're not talking about the intersection. So really, it can be any number on the number line, because the red is going to go forever to the left. This black line is going to go forever to the right, and it does overlap in the middle. But again, it can be one or the other. It does not have to be both. So x is an element of the real number system such that x is equal to the real number system. So x can be any number in the number system. Another way we could write it in interval notation is from negative infinity to positive infinity. So this means it includes all real numbers. Any number on the number line would make this work or this work. It doesn't have to make both. Okay, pause the video, and when we come back, we will do these together. Okay, guys, on this one, I'm going to show you how you can solve it just here, instead of breaking it down into two separate ones. But again, you can break it down into -2 less than or equal to 2x plus 4, and 2x plus 4 is less than or equal to 6. So I'm going to subtract 4. So I'm going to subtract 4 here and here as well. So I'm going to get -6 is less than or equal to 2x is less than or equal to 2. Then we're going to divide everything by the 2, and I get -3 is less than or equal to x, which is less than or equal to 1. So this ends up, and when we do our set builder, we'll just stick this on the end of the French curly bracket. So this is nice when you do it just without breaking it apart. So when we graph this, we're going to have -3 and then some numbers in between. I'm not going to count them up to the 1. And x is greater or equal to -3. And so the -3, which is here, is included. and it's greater than, but at the same time, x is less than or equal to 1. So this 1 is included. And so it's all this that's in between. And so for set builder, x is an element of the real number system such that -3 is less than or equal to x and less than or equal to 1. So see how that just, when you, without separating it, you get the exact notation for set builder. Now let's take a look at interval notation. And let's put our little, we don't really need these because we're not going in those directions because it's going to stop, because it has to be true for here and here. And both numbers are included, so we're going to use brackets. So we have -3, 1, bracket. Okay, now we have an or, so we're going to subtract 2 from both sides of this equation. We have 3x is less than 9 divided by the 3. X is less than 3, or we're going to add 6 to both sides. We're going to divide by -2. So remember what that does. We're going to reverse and say x is greater than +6. So let's graph this. Hopefully yours is a little bit neater than mine. So we're going to have a 3, 4, 5, and 6. So our first one, it says x is less than 3, not included. Going from 3 to -infinity. And then on this side, 6 is not included, and it's greater than. So here is our solution set and set builder. X is an element of the real number system such that, so x is less than 3. And then we also have, and we're going to use the union. This just means it's either this or this. And then we have x is greater than 6, French curly bracket. So now let's do interval notation. So we have from -infinity up to the 3. And then we also have from 6 to +infinity and nothing in between. So we're just going to unite this with this. So we're going to use the u. So we have our first one is -infinity, 3, union 6, +infinity. So this just means union, that we're going to unite this with this, and those are your solution steps, leaving this as a gap.